Okay, thank you very much for that gracious introduction. It's really a pleasure to be here in Australia again. We were trying to figure out, I think I've been here 5 or 6 times, and each one says I need to come back soon. Anyway, I want to talk today a bit about, let's see if we got it, machine learning, data, and competition. So it's 3 different topics, and I'll try to stick to my 20-minute allotment. A lot of interesting things to discuss in this area. And I want to start with machine learning. So in machine learning, artificial intelligence has been around for a long time in the laboratory mostly. Machine learning has been around both in the laboratory and also in business practice. So it's something that's really been used quite extensively in a number of different areas. The last 5 years, we've seen a huge boom in machine learning that's been driven by the incorporation of artificial intelligence methods into that subject. So we've had particular progress, which I'll describe in more detail in a few minutes, on image recognition, voice recognition, machine translation, and a few other places. Now, the progress that we've seen has come from having better algorithms, from having better hardware, from having more expertise, and of course from having more data. And one of the things I'll try to do in this lecture is assess the contribution of these factors of production to the progress that we've seen in machine learning. Generally nowadays, the hardware and software is pretty easy to find because you set up a cloud account at Google or at Amazon or Microsoft or one of the other providers, and you will have state-of-the-art software, state-of-the-art hardware that you can use for doing your machine learning tasks. And the data is often easy to acquire, not always, but often easy to acquire. The really scarce factor is the expertise, because there's so much demand now for trying to apply machine learning that people who really have the experience in that area are quite scarce. But thanks to the universities, they're educating people in this area, and the online world contains a lot of really fantastic tutorials. So we think that expertise problem will be eliminated in the next few years, or at least reduced. So here's some nice examples of machine learning from Kaggle. Let me ask, how many people know Kaggle? A lot. Why is that? Because it started right here at Melbourne. Anthony Goldbloom was a student here, worked also at the Treasury, as I understand. And he and his colleagues saw the Netflix contest, the Netflix prize. Netflix had a recommendation system. 75% of the choices that people made for the Netflix viewing were driven by that system, and they wondered, is this the best possible system, or is there a way to improve the system we had? And the way they decided to see whether it could be improved is they offered a $1 million prize. And they said, if you can improve our system by at least 10%, we will hand out this $1 million prize to the party that does the most improvement. So it's a quite interesting story associated with that, but I don't want to describe it in detail. What Anthony realized was that you could generalize this to many other cases. So if you have data but no expertise, and I have expertise but no data, there's something to be said for trying to match this up, and particularly matching people up by using this kind of competition. So these are some examples of actual competitions on Kaggle. Some of them are running now. Zillow, which is a real estate, online real estate company in Seattle, had a home price prediction model that they used to estimate the selling price of a house. And again, they wondered if it could be improved, so they've offered a $1.2 million prize to whoever can improve their prediction the best. Traffic to Wikipedia pages, personalized medicine, taxi trip duration, cervical cancer screening, and so on and so on and so on. All of these are cases where a business or a nonprofit had a prediction problem that they wanted to get a good algorithm to solve, and so they went to Kaggle, and thousands of data scientists work on trying to win these competitions. So it's quite an interesting example, and it's fun. Just go to Kaggle and look at the titles and descriptions of the competitions they've run, and you'll get a very good idea of what machine learning can be used for. So it's nice from that point of view. So let me say a few words about data. The very first lecture in information science is to show this data pyramid where you have data at the bottom. You collect and organize the data, that produces information. You analyze the information, that produces knowledge. You learn from the knowledge, that produces understanding. So the model is starting at the bottom with the raw data. Raw data itself is not really worth that much. You've got to analyze it and process it to be able to come up with information, knowledge, and understanding that help you apply the data in real-world problems. So some people say data is the new oil, and my view is, well, it's like oil in one way. It has to be refined in order to be useful. And in fact, when you look at that data pyramid, it's all about refining the data from into information and into knowledge. From an economic point of view, unlike oil, data is non-rival. If I have a barrel of oil and I give it to you, I'm not sure it'd accept, but I lost a barrel, you gained a barrel. But if I have some data or some information and I share it with you, we both have the same data, the same information. And because of that, the concept of data ownership, I think, is too limiting in terms of the economic transactions that you can conduct with data. You should be thinking about rights to data, permissions to data, licensing, regulation, private contracts, all sorts of ways of engaging in economic transactions around data that are not limited to this relatively simple concept of ownership, which goes along with most private goods. Instead, we should think of data as what economists call a club good, one that's non-rival, can be shared easily, but it may or may not be excludable in terms of preventing somebody from accessing the data. So something like temperature data, well, any of us could measure temperature data, and so there would be no exclusion there. In other cases, there might be exclusion, but the critical part is the non-rival nature of data. And this, of course, brings you to the question of data portability. So if you look, for example, at Google, we have had a service called Google Takeout, which has been around for 7 years and under a few different names, where you can download any of the data that you have provided to Google, your email data, your images, your photos, your documents have created, et cetera, et cetera. But one of the things we discovered is we had this capability to take out the data, but there was very little take in. That is, once you've taken out your email data from Google, then what do you do with it? Well, you might want to put it in somebody else's email service. And in fact, now we just announced a few weeks ago this data transfer project where the big internet companies, particularly the founding ones, Google, Facebook, and Twitter, are offering APIs that allow you not only to take data out, but also to plug data in and do this kind of transfer from one provider to the other. And we think that's an important thing to do, and really have encouraged other companies to join this coalition on data portability. Where does data come from online? Well, typically, or often, it's a byproduct of operations. Many companies have invested in putting in data warehouses where they've got a system that moves data from the point of sale, for example, into aggregation, into a warehouse where subsequently analysts can extract that data and analyze it the way I described earlier. You can get data from web scraping, from offering a service, hiring human beings to label data, buying it from providers, sharing it, and lots of other examples. I will mention the Google 411 example. When mobile phones started to become popular, we realized we should get into voice recognition. It was going to be a very important way to enter and access data via mobile devices, but we had no expertise, we had no data. So the first thing we did is we went out and we hired the expertise. We got the best people in the world on voice recognition, and then we said, figure out how to get some data. We created a system called Goog 411, which was basically a telephone directory for mobile devices. So you got your phone and you said, I need the number of Joe's Pizza on University Avenue in Palo Alto. And it would say, do you mean John's Pizza on University Avenue? But no, I mean Joe's Pizza. And after doing this for a few weeks and a few months, we had this huge repository of voices requesting numbers, responding to the requests from individuals. That allowed us to jumpstart our voice recognition system, and then as we got more and more actions that could be conveyed by voice, we got a more and more accurate system. So now, of course, voice recognition is really phenomenally good compared to what it was like even just a few years ago. And just last week, or maybe 2 weeks ago, we announced this Google Dataset Search, which is basically a specification for creating the metadata to describe a data set, and then you can search for data that might be relevant to your particular problem. Climate data, astronomical data, economic data, all sorts of data. We want to make it easy for people to find, just like search results are easy. There are a number of public data sets that are used for training machine learning artificial intelligence models. OpenImages has 14 million labeled images. We contributed several million images to that particular repository. By labeled images, I mean you've got a photograph plus a description, a human-generated description of what's in that photograph. A dog, a cat, a mountain, a river, a tree, a flower, whatever it is. And if it's a dog or a cat, you want the breed of the dog or cat and the identity of the flower and so on. Video understanding, we generated 8 million labeled YouTube videos. So lots of image recognition software can now recognize objects, but it's much harder to recognize actions. So if you see a video, a human being can look and say, oh, well, they're dancing, or they're fighting, or they're exercising, or they're marching, or they're doing this or doing that. But computers at this point are pretty bad at identifying that kind of activity, which is why we set this up as a Kaggle contest to use the machine learning artificial intelligence techniques to try to recognize the labels associated with this video search. Voice data, web data, click-through data, street maps. The Kaggle data sets are 6,784 as of a particular time I created this slide. And one of the great contributions of Europe is all of this 21 languages translation of European Parliament proceedings. So you have parallel documents that are all saying the same thing, but in 21 different languages. 6 million words, 30 million sentences, which has been a fantastic boon to machine translation, having access to that data. Now, people always ask, okay, we've got hardware, we've got software, we've got expertise, we've got data. How important are each of these different components to actually doing machine learning and artificial intelligence? And here's one nice example. The ImageNet data that I referred to a few minutes ago, 14 million labeled images, they would choose 1.2 million of those at random and provide that to computer scientists who were training their image recognition systems. And they did this from, 2011 up to 2017 in this particular chart. And you notice, by looking at that chart, that's the error rates from doing this kind of image recognition took a tremendous drop around 2012, 2013. So we've seen a dramatic improvement. The dotted line is human recognition of images, and you can see around 2015, we saw the computer image recognition surpass the human recognition in terms of accuracy. Now, Important point, this is all with a fixed data size, 1.2 million in every case. So the improvements in this example are not due to having more data, they're due to improvements in the hardware, the algorithms, and the expertise for a constant data set. Another example of this, which is kind of fun, is this one. At Stanford, they compiled a data set of 20,580 images of dogs, 120 different breeds, all labeled, and they wanted the computer to be able to recognize all those different dogs. And you can see we've got diminishing returns to scale. The bigger the training sets, the more accuracy you get, but at a decreasing rate. And this is the same sort of chart for a different problem done on a log-log scale. So it's just emphasizing what I showed you. Now let me give you an example. Go to cloud.google.com/vision, and you take some of your photographs and just drop them into this box that appears on the screen. And you will get back a list of all the objects that the system recognizes in your photo. So here's an example. This is our cat, Luna. And over here on the right-hand side are the images or the objects that the machine has recognized there. And they say, hey, that's a cat, 99% sure. And a small to medium-sized cat, 92% sure. I see whiskers, 91% sure. And down there, I think it's entry number 5 says it's a ragdoll. Now, a ragdoll is a kind of cat. It's a breed. And not only did it recognize that it was a cat-like mammal, but it was, in fact, a particular kind of cat. And there is our cat on the right, and there's the definitive cat from Wikipedia of what a rag doll should look like, and by gosh, you can see it did a pretty good job. Better than I would do, that's for sure. And this is, it's interesting, how do you access these kinds of services? Well, one really nice thing is you could just go to, I showed you going to Google, but you could do the same thing if you went to Amazon, if you went to Microsoft, and so on. And in fact, to do that kind of image recognition is now about 1/10 of a cent per image, with quantity discounts if you're doing many thousand or million images. So the technology that took these vast data centers and these very high-powered processing units and the expertise and software was developed are now available to anybody who wants it for fractions of a cent. And it gets lower every month. And this is an instance, I think, of what online competition looks like in general. If we take the big internet companies, Amazon, Apple, Google, Facebook, and Microsoft, they have an unusual industrial structure in that each company has its own area of expertise where it's got a competitive advantage, but at the same time, they're competing quite intensely with the other companies. So think of Amazon, Google, Facebook, Microsoft. They're all providing online advertising. Think of operating systems where you've got Amazon, Apple, Google, and Microsoft all competing on operating systems, or browsers where everybody has their own browser, digital assistants, e-books, email, general purpose search, vertical, special purpose search. You see this incredible competition among these companies across the company boundaries because the information technology is so flexible. If you assemble a team of engineers and a set of hardware that can produce an advertising platform, you can probably produce digital assistants or e-books or email messaging and all these other examples. So it's really quite unusual compared to historical examples of industries that did one sort of thing. Here you've got industry where there's competition across all of these different areas. Here's an example of the virtual assistants. So a few years ago, Amazon came out with the Amazon Echo, which used voice recognition. You could converse with it, get answers to questions you ask. 9 months later, Google comes out with this. Amazon comes out with the Dot, the small version. Google comes out with the Home Mini. Now they've just released one with screens, so you've not not only have auditory information, but also visual information. And this is the norm, because if you think about it, you could have a world where Amazon only sold books, and Microsoft only sold operating systems, and Google only did search, and you'd have these silos where the companies were providing each of these different services. That's not the world we live in. We live in a world where the companies may have particular expertise in one area or another, but they're competing intensely against each other in the kinds of areas that I described in the previous slide. And great thing is, it's not just the big companies competing against each other, but it's small companies coming in and competing against the big companies. So we've seen the chart on the right is money raised by year from venture capital. This is US data only. And you can see there's been really quite substantial growth in the last 7 or 8 years. That last bar is 2018, but we're only halfway through 2018 when this chart was produced. And if you extrapolate, if the second half of the year is as good as the first half in terms of raising revenue, we'd expect to see this surpass the amount of money raised back in 2000 in the original dot-com boom. And it looks like pretty healthy growth, not this kind of explosive growth as we saw then, but growth over several years in a relatively smooth manner. In venture capital, it turns out there are about 4 times as many acquisitions as IPOs. So in my view, this is a very healthy phenomenon. Kaggle, I mentioned earlier, was in fact acquired by Google, and we acquired Kaggle because we wanted them to design the perfect environment for doing data analytics, on having the data systems available, the databases available, the analytic tools, be able to call up 1,000 machines if necessary to do your processing on a particular set of issues. And Kaggle was very well poised, I think, to provide that expertise because they were in the community, they were in the business of connecting together the people with data to the people with expertise and analytic skills. So what could be better in terms of coming up with a way to, in fact, create an environment that the data analysts could use to solve the problems that they faced and access the data that they possessed. So I think maybe that's a good point to stop, and we can shift over to a little Q&A. Thank you.